T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Liftoff. Now control. Roger, roll, Challenger.
Good roll, flight.
Roger, good roll. Good roll program confirmed. Challenger now heading down range.
Throttle down at 94. 94.
Engines beginning throttling down now at 94%. Normal throttles for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells,
65,
3 good APUs.
TDL confirms throttles. Thank you.
Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles.
Throttle up, 3104. Capcom, go at throttle up.
Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Challenger, go at throttle up.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles, downrange distance 7 nautical miles.
Fido, trajectory. Go ahead. Trajectory, Fido. Flight Fido, filters got disconnecting sources. Here we go. Flight GC, we've had negative contact, lost downlink. Okay, all operators, watch your data carefully. Flight Fido, till we get stuff back, you don't have cue card for report logs. Procedures, any help? Negative, flight, no data.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Flight GC, negative downlink. Copy.
We have no downlink.
Flight Fido.
Go ahead.
RSO reports vehicle exploded.
Copy. Fido, can we get any reports from recovery forces?
Stand by.
GC, all operators, contingency procedures in effect.
We have a report from the flight dynamics officer that the vehicle has exploded. Flight director confirms that. We are looking at checking with the recovery forces to see what can be done at this point.
Fido flight, go ahead. LSO and recovery forces, any contacts?
Contingency procedures are in effect.
We're working with the flight. Okay.
We will report more as we have information available.
Flight Fido, for what it's worth, filter shows them on the water. Copy.
Fido flight.
Go ahead.
Did the RSOs have an impact point?
Stand by.
28.64 north, 80.28 west.
Reports from the flight dynamics officer indicate that the vehicle apparently exploded and that impact in the water at a point approximately 28.64 degrees north, 80.28 degrees west. We are awaiting verification from as to the location of the recovery forces in the field to see what may be possible at this point. And we will keep you advised as further information becomes available. This is Mission Control.
Okay, everybody, stay off the telephones. Make sure you maintain all your data. Start pulling it together. Final flight.
Go ahead, sir.
Are the LSOs on the loop?
We can get them.
Get them up on this loop, please.
Yes, sir. It's the LSO.
Okay, are there any forces headed out that way?
Yes, sir. DoD LSO reports that all soft forces have been scrambled and they are on their way.
Recovery forces are proceeding to the area. Flight controllers reviewing their data here in Mission Control. We will provide you with more information as it becomes available. This is Mission Control, Houston.
Flight of the Space Shuttle Challenger on Mission 51L began at 11:38 a.m. on January 28, 1986. It ended 73 seconds later in a structural breakup of the external tank and orbiter in which the 7 crew members perished. The weather was forecast to be clear and cold. Ice had accumulated on the launch pad during the night. The air temperature at launch was 36 degrees Fahrenheit. This was 15 degrees colder than any previous launch. 6.6 seconds before launch, Challenger's liquid-fueled main engines were ignited in sequence and run up to full thrust. Thrust from the main engines bends the shuttle stack. When it returned to vertical, the solid rocket boosters ignited. After the initial pre-release twang motion, structural forces on the assembly are dissipated through vibration at a rate of 3 cycles per second during the first few seconds of flight. This greatly exaggerated computer animation depicts the flexing of the SRB joint. This flexing increased the gap between the tang and clevis at the location of 2 rubber O-ring seals. At 0.678 seconds into the flight, a strong puff of gray smoke can be seen spurting from the vicinity of the aft field joint on the right solid rocket booster. The vaporized material streaming from the joint indicates there was not complete sealing action within the joint. This second view is from camera E60. The smoke can be seen between the right SRB and the external tank and initially moves in the upward direction. The multiple smoke puffs occurred at a rate of about 4 times per second, approximating the frequency of the structural load dynamics and resultant joint flexing. A third, higher resolution camera recorded this view of the smoke at approximately the same time of maximum development. Smoke appears to the right side of the SRB only, while normal water condensation vapors appear to the left. The first evidence of flame appeared on the right solid rocket booster at 58.788 seconds. This occurred as the main engines had been throttled up to 104% thrust and the SRBs were increasing thrust. Within half a second, the flame had grown into a continuous and well-defined plume. At 72.2 seconds, the guidance system showed that right SRB motion diverged from the orbiter and left SRB, indicating that the lower ET SRB strut was severed or pulled loose. At approximately 73 seconds, both liquid hydrogen and liquid oxygen pressure to the main engines showed a significant drop. This was followed at 73.124 seconds by the appearance of a circumferential white pattern around the ET aft region, suggesting LH2 tank structural failure. 13 milliseconds later, at 73.137 seconds, vapor was observed at the inner tank, indicative of the liquid oxygen tank failing. Within milliseconds, liquid oxygen was observed streaming along the external tank. At 73.191 seconds, a flash was observed between the ET and orbiter that was immediately followed by the start of total vehicle breakup at 73.213 seconds.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
The actual vehicle breakup was essentially obscured from view by the vapor cloud which abruptly enveloped the vehicle. Hundreds of fragments were noted exiting the ET cloud. Those identified included the shuttle main engines, the left wing, crew cabin, and both SRBs. The crew cabin was seen again with the front end and top of the cabin visible. As the subject moved further away and dropped lower on the horizon, the quality of the image for visual analysis deteriorated rapidly. Long-range tracking cameras followed the SRBs through range safety destruct. The shock wave from the detonation of the linear-shaped charge on the right SRB can be seen clearly. Simultaneously, the left SRB was destroyed. The Presidential Commission concluded that the cause of the Challenger accident was the failure of the pressure seal in the aft field joint of the right solid rocket motor. As indicated on these pre-flight photos, the smoke emerged from just above the strut, between the SRB and ET, at a point along the longitudinal axis near the aft field joint. Film records of the assembly of the solid rocket booster were reviewed to determine any evidence of cause for the smoke. No evidence of O-ring defects was observed in any of the stacking photography. The hole in the solid rocket booster segments was the result of the joint leakage on the right-hand SRB, which was determined to be the cause of the accident.